This is the chapter 7 and 8 practice test. So this is our systems. This is just a practice test of review for the systems. So remember, we did the systems a couple of different ways. We did them by graphing, and we also did them algebraically. So let's see, what do we have on this practice test? This one, it says tickets for a school drama are $12 for adults and $9 for students. Now it says 500 people purchased tickets, 5478 was collected. Which is the systems? Now remember, adults and students, they're probably using A and S. A plus S is equal to 500. I know that that's a total, right? Because there's 500 people in total. So that's got to be one of the equations. That's wrong. A plus S is, that could be right. That could be right. No one knows. So it's got to be either C or D. Now the other one is the 5478. So that's the dollars, right? So the adults are $12 each. So 12 times the number of adults. And because it's a total, I'm going to go plus. So 9 times the number of students. And that should equal 5478. There it is. Yeah, this one's just got it backwards. So that one's wrong. So it's got to be C. Okay. Let's see, number 2. It says this system here and here has an infinite number of solutions. In other words, it means it's the same line, right? Because if it's an infinite number, it means it's the same line twice. Okay, well, they say, what is M? What is N? I don't know, but you know what? I'm going to start with this one because I know that 7x, move the 11 over, minus 11, right? Minus 11 from both sides, minus 11. And I'm going to go plus 2y over here and plus 2y over there, equal to positive 2y. Now, if I go divide by 2, this will tell me the slope and the y-intercept, but I don't think that's what I'm looking for here. You know what? Let's just back it up. I know that it's the same line, right? Because it says it's an infinite number of solutions. Well, let's see. What do we got? We got 7x and 2y is equal to 11. Well, this is twice as big. See? If it's the exact same line, that went times 2. Okay, well then, m, this is also times 2. Because if I just times 2 times everything by 2, I'm going to get the other thing, right? So 11 has got to be times 2. N has got to be 22. Maybe, maybe, no, no. What about 2? If I double this, I'm going to get minus 4. M is minus 4. There it is. It's got to be that one. Okay, that makes sense. Otherwise, I was going to get the slope and the y-intercept, but I don't know those. And in this case, they shouldn't have used m. We always think of m as the slope. No, in this case, m is just some letter. So they should have used a better letter than that. Okay, let's see. Which system of equations do we have here? Okay, I don't know any of these, but let's try and figure out the equation. If I do rise over run, so these are 3, 6, 9, 12. They're going up by, so this one's positive 27. So something's got a y-intercept of positive 27. And what's the rise over the run? It goes from this one, right? 1, 2, 3. So hang on, that's going up 3, and this is 2, 4, 6. Careful. So this is not 1/3. From here to here, because these are going up by 3s, this is 3, and this is 2, 4, 6. So the slope is actually a half. Slope is 1/2, right? The rise over the run. So this equation here is y is equal to 1/2 x plus 27. Now, is that one of them? I don't see. It could be this one, but they don't have the half. Let's see. There's no half. I don't see a half. What if they doubled everything? Times 2. So you get 2y is equal to 1x plus 54. Is that, ooh, that's close. 2y is equal to 1x plus 54. But they've got x minus 2y. Hang on. What if I minused off 2y to both sides? Here's what I get. I get 0 is equal to x minus 2y plus 54. Is that this one? See, the 54 comes over here, it becomes negative. Hey, that's this equation. This is not the same one because they didn't double the 27. So that could be this one. So that's that first equation, this one right here, right? Oh, I don't want that there. So what's the other one? Okay, well, let's see. What's the rise over the run for this one? This one is, if I'm going up 3, 6, 9, 12. This is like halfway. You know what? If this is a distance of 3, I bet you that's 2. So in other words, this is probably 14. I think the y-intercept is 14. Now what's the rise over the run? I don't know any points here. I do know that point dead on, right? Where's another point that is going through dead on? Well, hang on. I know it's going to be a negative slope, right? So this is up 14, but I'm not sure what these are. Notice this? That's a dead on point, right? I know that this is negative 6, and that's 24. See this? 6 and 24? I think that's what they're doing. So they're doing this one as a slope, point slope. So let's try and figure out this one is the 6 and 24 kind of thing. Could it be this one? Could it be this one? Let's see. What's the rise over the run? If this is 14, right? How much are we going up? We're going up 10. And how much are we going over? 2, 4, 6. 6. So the slope, so in this case, the slope is negative 10 over 6. So I could do this. Y is equal to negative 10 over 6, x, plus my y-intercept, which is 14. Hang on, that's 5/3, right? Y is equal to negative 5/3 x plus 14. I don't see that here. And remember, I thought it could be this one or maybe one of these ones. Let's get rid of the fraction. Let's times everything by 3, right? Because this becomes minus 5x. 14 times 3 is 42. 3y. Oh, I see it now. See that? Watch. If I bring this 5x over, I get 5x plus 3y is equal to 42. There it is. That's the other equation. So that was a tough question because there was an awful lot of different points that you could use. There's a lot of different ways of doing this. Yeah. And I'm going to say that that was 14. And I'm going to do this one. So this one is actually for this over here. That was this one, and this one was this equation. Okay, hang on. It says two linear equations has no solution. Well, that's one solution. If there's no solution, that means that these two are never ever going to cross, which means they are parallel. They usually write them with like little arrows like that, which means two parallels. Got to be D. Okay, how about this one? Let's determine the solution. So first off, I'm going to do this one. If the y value is 5x plus 1. Okay, and here's my different x values. We're just going to figure them out. So 5 times 2, 10 plus 1, 11. Plug in 1, 5. 5 plus 1 is 6. Plug in 0. 0 plus 1 is 1. Negative 1. So negative 5 plus 1, which is negative 4. You probably see a pattern. These are going down by 5. Minus 5, minus 5, minus 5, minus 14, right? I think that's the last one. Minus 15 plus 1, minus 14. Okay, so now let's do it for the other one. So 2/3 of 2, or 2/3 of 2. So 3 over 2 times 2 minus 6. So that becomes 3 minus 6, which is minus 3. Take in 1. So 3 over 2, which is 1.5, minus 6. So 1.5 minus 6 is going to be actually negative 4.5. Right? Because this is 1.5 minus 6. Okay, let's plug in 0. 0 minus 6, minus 6. Let's plug in negative 1. So negative 3 over 2, which is negative 1.5, minus 6, which is going to give me negative 7.5. Oh man, is this going to work? Take negative 2, plug it in. So 3 over 2 times negative 2, which is negative 3, minus 6, which is going to be negative 8. 3. Okay, so 3 over negative 3 times 3 over 2. So negative 9 over 2, which is negative 4.5, minus 6, which is going to be negative 10.5. Okay, hang on. So are these getting close together? This is the closest one here, right? So here they are 2, 1, going down by 5. So this is really close. So determine the solution. It's not going to be a very nice, so it's going to be close to negative 2 comma negative 9, right? The x and the y value. It's probably like 8.9 or 8.5 or 8, somewhere in between these two, right? But seeing these are far apart, these are far apart, this is the closest one to get together. So it's going to be a decimal. It's going to be close to that. So if you wanted to do that accurately, well, we'd have to do it algebraically. So from this table, it's kind of limited. Okay, it says determine whether or not this is the solution. So in other words, I'm just plugging in my x and y value and see if it works. So y, 0, is equal to negative x, so negative 4 plus 4. Yeah, that works. Now hang on, does it work over here? Y, 0, is equal to 2 times 4, 4 plus 4. This is 8 plus 4, which is 12. 0 is equal to 12. No, it is not the sleep. It works in this one, but it doesn't work in both of them, and it's got to work in both of them. Okay, let's try this one. The x value is 3, y value is negative 6. So negative 6 is equal to negative 3 times 3 plus 9. Negative 6 is equal to negative 9 plus 9, which is 0. No, doesn't work. Not at all. Okay, so that one's wrong too. How about this one? The x and the y. So I'm going to plug in the y value. 1 is equal to 2/5 times 0 plus 1. Yeah, 0 plus 1 is 0. That works. Let's try this one. 1 is equal to negative 4x, so negative 4 times 0 plus 1, 0. Yes, that one works as well. So yes, this one is a solution. Okay, let's try and figure this one out graphically. I'm going to have to graph both of these. First thing I'm going to do is I'm going to rearrange this. Plus 1, plus 1. So I get y is equal to 1x plus 1. I know the slope. I know the y-intercept. What about this one? Plus 7, plus 7. Y is equal to 2x. Well, it's 2 over 1. Rise over 1. Plus 7. So this one's going to be a y-intercept of 7. And this one is a slope of 2. This one has a slope of 1. Okay, so I need to graph this thing. One's going to be going up this way and one's going to go that way. So where to begin? I'm not sure. So I'm just going to draw a graph here. I'm going to put it around there because 7, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2, 4, 6, 7. And this one has a slope of 2. So it's going to go up 2 over 1, up 2 over 1, up 2 over 1. I can even go down 2 over 1, down 2 over 1. Right? So there's that first line. Let's see. Let's do it for the other one over here. I'll do this one in, let's do this one in purple. Okay, so what did we have here? Excuse me. We had y is equal to 1x plus 1. So this one has a 1 and it's going up and over 1, up 1 over 1, up 1 over 1, up 1 over 1. Oh, so this one's going to meet, I really should have moved my graph over. So there's this line. And where's my blue line? There's my blue line. I should have centered my graph. But hang on, let's see if I can continue this one on. So this is 1, 2, 3. This is minus 4, 5, 6, 7, 8. Minus 8, right? And this is going down 1, then down 3, and then down 5. So if I go 1, 2, 3, 4, 5, 6, 7, 8. So if I go minus 6, it should be down 5. Is that the same as this one? Right? Minus 3, positive 4. Down 1 and over, which puts it here, and then down 1 over. So yeah, it's going to be the same point. minus 5, and minus 6. So the point of intersection is minus 6 and minus 5. Now that's from a graph. That's an estimation. Really, I should have taken this whole graph and moved it over there. You probably do it a better graph than that one. If you centered it here, right? If I was to take this entire thing and move all this stuff over, I'd have a much more accurate graph. I'm willing to bet yours is probably better than mine. Okay. How about this one? We're going to have to rearrange here, right? So 6y is equal to minus x minus 7, right? So I'm just going to move that x over. Now, if I go divide by 6, divide by 6, divide by 6, ooh, this is not very good, is it? Y is equal to negative 1/6 x minus 7/6. Not a very nice number. What about this one? Okay, let's move the two x's. So 12y is equal to negative 14. Oh, hang on, I gotta go minus off 2x. Let's do that first. Minus 2x minus 14. And then divide by 12, divide by 12, divide by 12. So here I get y is equal to negative 1/12 x minus, hey, it's the exact same thing. It's the same line, which means they intersected an infinite number of points. Right? It's not just one point. There's an infinite number of points. And I'm not actually going to graph that one because this is not a very nice one to graph, right? I can't estimate 7/6 very well. I can do this rise over the run, but I don't need to actually graph it because I can tell that they're the same line right now. Now, if this was on a test, maybe this question would be different in that this would be like 100 or something like that. These would be the same slope, but different y-intercepts, which means that they'd be parallel and there'd be no solution, right? If they're parallel lines. However, we didn't make this one 100. This is 7/6. It's the exact same line. Okay, who's next? What about this one? 3x plus y minus 1. Okay, let's solve for y. Minus 3x minus 3x plus 1 plus 1. So here's what I get. I get minus 3x plus 1. I can graph that, right? Slope, y-intercept. Let's do this one. So I'm going to, instead of moving all this other stuff over, I'm going to move the 2y over. 2y is equal to x minus 26 because now I'm going to go divide by 2, divide by 2, divide by 2. So in other words, here's what I got. I'm going to do this one in purple. I'm going to get y is equal to 1/2 x minus 13. There's my slope. There's my y-intercept. Whoa, this one's going to start down 13. This one's going to start up 1 with a slope of negative. Okay, so who knows where this one graphs. But I want to be down 13, right? 2, 4, 6, 8, 10, 12, 14. Let's figure this out. Okay, so this one starts down 13, 2, 4, 6, 8, 10, 12, 14, minus 12. So I'm going to start here. And my slope is 1/2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And I can also go down 1 over 2. Down 1 over 2. Down 1 over 2. Okay, so there's this line. Not a very fantastic line, but I can get the idea. What about this one? Starts at positive 1 and it has a slope of negative 3. Okay, so this one starts at positive 1 and it's negative 3. So it's going to go down 3 and over 1. And it goes in this direction, right? Because negative slopes go this way. Down 3 over 1. Down 3 over 1. Down 3 over 1. Ooh, 1, 2, 3. There it is. There's the intersection point. I got lucky on this one. So I can see, now this is not a terrific graph. It's kind of, it'd be way better if I had a ruler. Yeah, I don't have a ruler on here, but you know what? That's why I made my dots nice and big so it's pretty obvious. So this is down 11. 1, 2, 3, 4. So here's my intersection point. 4 to the right, minus 11. I should probably pull this x and y. There's my x and y axes. Okay. How about this one? It says Shirley and her younger brother Aaron differ by 6 years. So he's younger, right? She's older. Okay. She's 6 years older. It says half of Shirley's age is 2 less than Aaron's age. Develop a system. Okay, well, we need two equations, x and y, and I'm not going to use x and y. I'm going to use s for Shirley and a for Aaron. Shirley's age, and this is Aaron. Aaron's. Come on, get ready there. Aaron. Aaron's age. Now, we know that Shirley is older. So Shirley is equal to Aaron's age plus 6, right? Because she's older. If you take the younger age, you add on 6, you get Shirley. Okay, that's one equation. What is the other one? It says half of Shirley's age. Okay, so Shirley divided by 2 is equals 2 less than, so it's going to be something minus 2, Aaron's age. So Aaron's age is just A. So there it is. Half of her age is equal to Aaron's age minus 2. Now, the domain, hang on, we haven't talked about domain. What domain and range and stuff like that really means what kinds of numbers. It cannot be all real numbers. We can't have negatives. You can't be negative, right? That's all this really means. I wouldn't put a question like this on a test, but I would say, can you have positive and negatives? No, you can only have positive numbers. You can't have negatives, so it can't be all real numbers. Okay, graph this thing to determine there. Okay, so this is going to be one equation, S, and it kind of looks like y equals mx plus b, right? Because I solved for Shirley. And so let's say the y-axis is S. Doop, 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 doop. Well, you know what? In fact, I'm not going to put it there because that would give me negatives, negatives. No, I'm just going to do this. I don't need to use all 4 quadrants of the graph because I'm only using positive numbers, right? Which means I can just use the top right corners. Okay, so instead of y, I call this s, which means this one's got to be a. So y is equal to mx plus b. Well, this was 1x plus b plus 6. Okay, so let's count by 6. 2, 4, 6. Right? 8, 10, 12, 14, 16, 18, 20. 6, 8, 10. So here's this first equation. Y equals mx plus b. The slope is 1. Y-intercept is 6. So I'm just going to go up 1 over 1. Up 1 over 1. Okay, so this is the first equation. Doop, 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 doop. And yeah. So if I'm doing up 1 over 1, that means I have to use the same scale. So 2, 4, 6. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16. Okay, what's the other equation? It says s over 2 is equal to, now you know what? Let's take that and let's rearrange it. So this one was s is equal to a plus 6. It's 1a. And this is s over 2 is equal to a minus 2. You know what? I'm going to double this because it becomes s instead of s over 2. So 2a minus 4. Minus 4, we're going to start down 4. Oh man, maybe I do need the negatives, but I can't. 1, 2, 3, 4. How do we start? You can't be negative h, but this is where this line starts. And it's going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Ah, this is where it starts actually. Now I can actually start doing it. Up 2 and over 1. Up 2 and over 1. Slope is positive 2. Oh, we're getting closer. We're going to get closer to an intersection point. Up 2 and over 1. There it is, right there. I'm going to put a nice big dot there. Up 2 and over 1. Up 2 and over 1. So now I can actually see the intersection points. And there's only one. Now, this line shouldn't really go on, should it? No, it shouldn't. this line should really just go to here and stop. Same thing. This line should not go on forever. It should go on to there and stop. Okay, so what is this? This is the point 10, and the y value is 12, 14, 16. Okay, so graph the system. How old is Shirley? How old is, okay, well, is Shirley 10 or is she 16? Shirley is the y value. Shirley 16. Oh, there we go. Shirley is 16. Aaron is 10. Yeah, because Aaron is the x value. In other words, it's the a. Okay, let's do this one. Determine the exact solution algebraically. Okay, so substitution. That's where you solve for either x or y or something, and you plug it into the other one. Okay. I could either start with this first equation or this second one. You know what? I'm going to take this one. I'm going to move it over here. 5r minus 2s plus 18 is equal to 0. And this one, I'm going to isolate r. I'm going to get r all by itself. So in other words, move the 2s over. So r is equal to, minus off 2s from both sides, so 0 minus 2s. Now, whoa, I don't need that. Here's what I'm going to do. R is equal to 2s. This is going to go right into there. See, this is a substitution. So I just plug it straight into there. 2s is going to go into there, not into there. R is equal to 2s, so wherever I see the R, I'm going to replace it with a 2s. So here we go. 5 times R minus 2s plus 18 is equal to 0. Okay, so what do we got? We got minus 10s minus 2s plus 18 is equal to 0. So this is minus 12 s's plus 18. Let's move the 18 over. Minus 18, minus 18. So in other words, minus 12 s's is equal to minus 18. Okay, let's solve for s. S is equal to negative, negative. That's positive. 18 over 12, divide out 6. That's 3 over 2. In other words, it's like 1.5 or 1.5. So that's not the answer. That's just the first one. Now, if I want to figure out what the other one is, I go back. But look, remember this? R is equal to this. I can just substitute it right back in. R is equal to minus 2s. Well, R is equal to minus 2 times 1.5. So in other words, R is equal to minus 3. So there's my other answer. So S is equal to this, R is equal to that. Now, quite often, if they give it to you as in like an X and Y coordinate, they usually do them alphabetically. A, B, C, D, F, G, H, I, J, K, L, M, N, Q, R, S, T, U, V, W, or Q, R, S. So I'm going to put the R first. Minus 3, and then 3 over 2. Or you can say 1.5. Same thing. You know what? If you're not sure, just put R and S above so we know which is which. Okay, what do we got left? We got this one. I want to do substitution. So this is the one I'm looking for. I don't want to divide everything by 3 or 4 or 6. I want to isolate y. So let's go plus y to both sides. So this one becomes 6x is equal to 1 plus y minus 1 minus 1. So 6x minus 1 is equal to y. That's what I'm going to substitute in. And I'm going to substitute it in here. 4x minus 3y is equal to minus 4. So remember, 6x minus 1 is going to go right into there because that's what y is. So here we go, 6x minus 1. Now this looks like a bigger equation. However, it's just x, so now I can actually solve. 4x minus 18x plus 3 is equal to negative 4. Okay, so this is like minus 14x plus 3 is equal to negative 4, minus 3 minus 3. Minus 14x is equal to minus 7. Hey, this is going to work out nice. Look, here's what we get. We get x is equal to positive a half, or 0.5. Either way. Now, what is the y value? I don't know, but you know what? This is where I come back now. Now I'm going to plug it in here. Remember, y is equal to 6x minus 1. Well, x is a half. So y is equal to 6 times a half minus 1. In other words, 3 minus 1, y is equal to 2. Okay, so here's my solution. X value is a half, y value is 2. Now, did they say check these ones? Let's do one quick little check here. Remember, if they ask you to check it, here's what you do. Step 1, write out the equation. 4x minus 3y is equal to 4. Sorry, minus 4. Step 2, plug in your x value. X is a half, so this is 4 times a half. And 2, 3 times 2. So is that equal to negative 4? I'm not sure. So this is going to be 2 minus 6, which is negative 4. Yes, it is. Ta-da! So that one actually works. Let's check it with the other one. 6x minus y is equal to 1. 6x minus y equals 1. The x value is a half. 6 times a half minus y value is 2. So this is 3 minus 2. That's 1. Yes, it works. So if it works in both equations, it is the answer. Okay, let's get down to the last ones here. Solve the following systems using elimination. So this is where you put one on top of the other and you add and subtract. Okay, so let's see. X's are lined up, Y's are lined up, numbers are lined up, equals are lined up. Yeah, so I want these lined up. That works. Even the equal signs have to be lined up, and then the right-hand side is just 0. So sure, this will work. Now, here's the problem. These are not the same. 5x, 10x. But if I double the first one, it'll become, yeah, so that's what I'm going to do. So I'm going to do this one times 2. So I'm going to equate the coefficients. Equate the coefficients. In other words, I'm going to make the coefficients the same. So if I double it, I get 10x minus 4y minus 16 equal to double 0, it's still 0. So I doubled everything here, right? You do it to one side, you do it to both sides of the equation. What about this one? Leave this one alone. Don't change anything because it's already 10x. Here we go. So 10x minus 10y minus 37 is equal to 0. So do I add these? No, if I add them, they don't cancel. I'm going to subtract them. 10 minus 10, 0. Minus 4 minus minus 10. Minus 4 minus minus 10 is plus 10. That's 6y. Minus 16 minus minus 37. Minus 16 minus minus 37 is plus. This is going to be 21. Plus 21 is equal to 0. Let's solve. 6y minus 21 from both sides is minus 21. Divide by 6. Divide by 6. So y is equal to, this is, I can take out 3. I get negative 7 over 2. This is negative 3.5. So once I get one answer, how do I get the other one? Well, I'm going to plug it back into any equation I want. This one or this one, go to the easiest one, right? Let's get rid of the stuff. 5, 2, and 8, that was a smaller one. So 5x minus 2y minus 8 is equal to 0. So now I'm going to take this and sub it back in. Y is negative 3.5, right? So 5x minus 2 times negative 3.5 minus 8 is 0. What do we get? 5x plus 7 minus 8 is equal to 0. So this is 5x minus 1 is 0. Or in other words, 5x is equal to positive 1. X is equal to 1/5. There we go. So there's my y value. There's my x value. I'll do them both as fractions. So here's my solution. 1/5 and negative 7 over 2. If I had done them as decimals, this would be 0.2. 0.2 and negative 3.5. It's the same thing. Oh man, look at how ugly this one is. But you know what? I can get rid of all these fractions. Remember? 2 and 3 has an LCD of 6. Times both sides by 6. What does this become? 6 over 2, 3x, minus, hang on, what's 6 times 2 thirds? That's 12 thirds, which is 4y, equal to 36. Okay, that's nice. That's way nicer. What about this one? What am I going to times this one by? 4 and 3, times it by 12. Okay, so if I go times 12, I get 12 quarters. That's 3x. And 12 times 4 plus 4y, 12 times 1, equal to minus 12. Hey, that was pretty slick because x's line up, y's line up, equal signs, and numbers line up. Everything lines up. You need these to line up in order to do elimination. Okay, so now what? Do I add these two together or do I subtract them? Well, it depends. Do you want to cancel out the x's or the y's? I could subtract and cancel out the x's, but notice, look at this. Negative 4y plus 4y. This will work. If I add these are going to, adding's way easier. 3x, 3x, 6x, 0. And 36 minus 12 is 24 divided by 6. X is equal to 4. Ta-da! That was pretty easy. Now what? I need to sub it back in, right? But I'm not going to sub it into one of these ugly ones. I'm going to sub it into something easier, an easier equation. Let's use this one. 3x, 4y equal to negative 12. 3x plus 4y equal to negative 12. Now, if the x value is 4, plug it in. So this is 3 times 4. So this is going to give me 12, right? 3 times 4 plus 4y is equal to negative 12. 12 plus 4y is equal to negative 12. Subtract off 12. So 4y is equal to negative 24. Here we go. Y is equal to negative 6. So there's my x value, there's my y value. 4 and negative 6. Ta-da, that's the solution. Because the solution is the point of intersection. Okay, is this the last one? This is the last one. Okay, a word problem. Here we go. Tickets to a local baseball game are $17 for adults, and $8 for youths. So I'm probably going to use A and Y. So at one game, there's 1,200 people, and the total ticket sales are this. Let's go back to the very, very first question. You remember? We were talking about adults and students, and one of the equations was A plus S. That's just a total, right? 500 people in total purchase tickets. Let's go back. Okay, where do we go? Here it is. It's the same kind of question. There was 1,200 people in attendance. So if I'm going to say A equals number of adults, adult tickets, and Y is the number of youth tickets, youths. 1,200 in total, so I know A plus Y should equal 1,200. That's an easy equation, right? A total. The harder one is the money one. Okay, but let's see. The adults tickets are $17. So $17 for an adult ticket plus $8 for youth. $8 for youth ticket is equal to, whoa, 17,250. Okay, I need to grab myself a calculator. This are going to be some big numbers here. Now, how do you want to, we could do this by substitution. We could solve for A is equal to or Y is equal to, but look, I've already kind of set them up one on top of the other. It's just that I have to multiply this one by 17 if I want to cancel out the A's. Why don't we cancel out the Y's? So let's do that. So I'm going to do this one times 8. So here's what I get. 8A plus 8Y is equal to, well, 8 times 1,200 is 9,600. Yikes. And this one, we're not going to touch it. I'm going to leave it all 8y, just leave it as 8y. So 17a plus 8y is 17,250. Yikes. Do I add them? No, because these are the exact same. I want to subtract them. If I subtract them, these will cancel, and that's what I want. Okay, so 8 minus 17. Whoa, that's like minus 9a. Plus 0. So 9,600 minus 17,000. Okay, I got to plug that in. 9,600 minus 17,250. Whoa, 7,650. And it's negative 7650. Now, you can't have negative people, but hang on, I know these two negatives are going to cancel. So this is okay. So it's okay to have the negative here. I'm expecting those to cancel. So if I divide by that, I get A is equal to 850. Hang on, is that the answer? That's just the number of youth or the number of adult tickets. Now remember, it says there was 1,200 in total, so I can plug it back into either one of these equations. Hello, that's the easiest one right there. So let's plug it back in. A plus Y is equal to 1,200. I know A is 850. 850 plus Y is equal to 1,200. Well, subtract off 850, I'm going to get Y is equal to 350. Now, is that the answer? I should probably do a check. Now, I'm checking it in both equations. This is the easy one. A plus this is 1,200. Yeah, we can tell that. So 850 plus 350 is 1,200. Yeah, that's obvious. That's the easy one. Here's the harder one, the one with the bigger numbers. Okay, so 17A plus, what is it, 8Y. 8Y is equal to 70,250. Let's try it. 17 times A was 850, plus 8 times 350. Okay, so what's 17 times 850? Whoa, 14,450. And then 350 times 8 is 350 times 8. Hang on, 17 was 2,800. And if I add these two together, I get 14,450, 2,800, 0, 5, 12, take up 1, 6, 7. I get 17,000. Yes, it does work. So let's go back and answer the question. The number of youths, that's all it's asking for. The answer is 350. So 350 youths. Ta-da, there's my answer. Alrighty, so this was a long review, way longer than what the test for Friday is probably going to be, because I'm going to put a pretty straightforward one on there with some multiple choice, and then probably only like 1 or 2 word problems. So good luck with these, and look for it on the website.